Hey folks, got another viewer question for you in today's Wrath of Math lesson. On a lesson I did a while ago about converting fraction denominators, Mega Davis commented, "That's good, however, what if you want to change a denominator into a prime number denominator like 13? That's a good question. That's what we'll be going over in today's lesson. If you are not familiar with the basics of converting fraction denominators, I'll leave a link in the description to that lesson I did on it. I think it's a great lesson, so check it out if you want to see the basics. Let's quickly go over the basics here really quick before we go into the Messier examples. So say we've got a fraction like 3/5 and we want to rewrite it as an equal fraction but represented differently with a different denominator. We just have to remember that, of course, if we multiply anything, including a fraction, by 1, it doesn't change. We still have the same exact value. But we could change the form of the fraction if we were to multiply by a different version of 1. We could write 1 as 3 over 3, for example. Multiply the denominator by 3 and multiply the numerator by 3. That'll keep what we get equal to the original fraction, but it will have a different denominator and a different numerator. So this would be equal to 3 over 6. It's just another way of writing 1/2. And there are many reasons we might want to change a fraction's denominator. So we can get the denominator we want, we just have to multiply by the right form of 1. So there's some number we can multiply 5 by in order to get 20. Whatever that number is, we'll just multiply 3 by that number as well, and that'll give us our new equal fraction. So we're saying 5 times some number is equal to 20. We can find that number by dividing both sides by 5. So the number is 20 over 5, which is equal to 4. And so then we can convert our fraction, change the denominator, by multiplying the numerator and denominator by that number 4. 5 times 4, 3 times 4. 5 times 4, of course, is 20. That's how we found the number. And 3 times 4 is 12. So this is an equal fraction. This is equal to 3/5. It's just written with the denominator we want, of 20. This example, of course, worked very nicely. We've got an integer in the numerator and in the denominator. It worked out nicely because 5 goes into 20 evenly. But what if we have a Messier example? If we want to change the denominator into a prime number, for example, we might have something a bit messier. So let's say we have the fraction 9/10, and we want to rewrite it with a denominator of 13. 13 is a prime number, so certainly 10 does not go evenly into 13. We can change this fraction, we can change the denominator using the same exact process we just went over. It's going to be a little bit messier, but it's the same exact process. It works just fine. So there's some number we can multiply 10 by in order to get 13. Find the number and multiply the numerator and denominator by that number, then we're done. We have our fraction. So just as before, we can find the number by taking the denominator we want, 13, and dividing by the denominator we have, which is 10. So then, all we would have to do is multiply the numerator and the denominator by this number, 13 over 10. Of course, we could also rewrite it as a decimal and use that instead, 1.3. Not really going to change anything, just change the form of our answer. Let's first try multiplying the numerator and denominator by the fraction form, 13 over 10. So multiply the denominator by 13 over 10 and multiply the numerator by 13 over 10. This, of course, is going to give us 13 in the denominator. 9 times 13 over 10 is going to be 117 over 10. 100, oh, whoops, gonna have to write that a little higher. 117 over 10. So that is our new numerator. So obviously this isn't the most beautiful fraction in the world. You know, we've got this kind of ugly fraction as our numerator, but if you want to change a fraction to, you know, whatever denominator you please, you can't be super picky. You got to lose a bit of your pickiness about what the fraction is going to look like. But of course, if you want, you could also use the decimal form. So we could have gone from 9/10 to a fraction with a denominator of 13 by multiplying by 1.3. So multiply 10 by 1.3 and multiply 9 by 1.3. 10 times 1.3, of course, is 13. What about 9 times 1.3? Of course, you could punch it into a calculator. 9 times 1 is 9. 9 times 0.3 is 2.7. So add them together, that's 11.7. And this really looks nicer. So that's just another way of writing 9 over 10, our original fraction, in terms of a fraction that has a denominator of 13. They're equal, they just look different. And that's really all there is to it. We can write a fraction with whatever denominator we please using this same strategy. We just may not end up writing it in terms of an integer over an integer. We might have a fraction divided by an integer, or a decimal divided by an integer, or a decimal divided by decimal. You know, it could get as messy as you want depending on the decimal that you want. So let's just do one more example. Consider this fraction 8 over 15. Notice this fraction is fully reduced. We couldn't reduce this fraction anymore. It's a simplified fraction. But what if we want to write it in terms of a fraction that has a denominator of, let's say, 9? How would we do that? Well, we couldn't reduce the fraction nicely, keeping the numerator and denominator as integers, but we can still give it a denominator of 9 if we want. We're just going to sacrifice its nice appearance. So we use the same process. Take the denominator we want, divide by our old denominator, and then we could just go from there. Multiply the numerator and denominator by 9/15. So multiply by 9/15, multiply by 9/15. This, of course, is going to give us 9 in the denominator. 8 times 9 over 15 is 72 over 15. And there we go. There's another kind of ugly fraction. It's just a way of writing 8/15, but in terms of a fraction that has a denominator of 9. Just as we did before, we could also use a decimal. So we could rewrite 9/15 as, well, for starters, we could simplify the fraction. It's equal to 3 over 5, which is equal to 0.6. And then we could take our original fraction, 8 over 15, and multiply the numerator and denominator both by 0.6 to get the kind of fraction we want. So 15 times 0.6, 8 times 0.6. 15 times 0.6, of course, is going to be 9. 8 times 0.6, well, 8 times 6 is 48, so 8 times 0.6 must be 48 divided by 10, which is 4.8. That's just another way of writing the fraction 8 over 15 in terms of nines. Pretty cool. And it's as simple as that. Like I said, it could get as messy as you want depending on the denominator you want. You might want to write it in decimal form and you might have to do some rounding, but depending on the problem you're doing, that might be just fine. You know, sometimes we have a bunch of different terms and we want to collect them all into the same fraction and we don't really care how they look. We might not even care if we have to do some rounding. So sometimes we want to do this. We want to get some weird denominators. Here's just an example of a problem where you might use a strategy like this. Suppose we're trying to find a sum. Let's say we're asked to find the sum of 42 over 90 plus this fraction 8 over 15. You might say, you know, I don't even want to mess with trying to find the least common multiple of these two numbers. I just want to get them to a common small denominator. I don't even care if the numerators become ugly fractions or decimals. I just want to work with a small denominator. So you might say, well, 90 is a multiple of 10. So we could divide the numerator and denominator of this fraction by 10 and rewrite it as 4.2 divided by 9. And then we could just rewrite this fraction, 8 over 15, in terms of nines, which we already did. We know that's 4.8 over 9. So this is 4.8 over 9. And 4.2 plus 4.8 over 9 is going to give us 9 over 9. Hey, look at that. It's equal to 1. Of course, the more normal way to solve this problem would be to notice that 15 goes evenly into 90. We could multiply both the numerator and denominator by 6, and we could rewrite this sum as 42 over 90 plus 8 times 6 is 48, and 15 times 6 is 90, and we'd get the same thing. This is going to be 90 over 90, and it's equal to 1. But this is another way that you could do it. You can make whatever denominators you want and you can use this process to do it every time. So I hope this video helped you understand how to convert into strange, untraditional fraction denominators. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I will see you next time, and be sure to subscribe for the swankiest math lessons on the internet.
When I gotta let go, this shit makes you think all the time. Fantasizing on the way low, gotta get it the fuck out of my mind. I'm thinking hard, I'm stuck sleeping on my side. Don't look at stars when my demons show the ride. Never know it's not us, yeah. Thinking of the consequences when I'm falling.